So for this one here, they give me the hypotheses, they give me the critical, they give me all that stuff. And then they like to do questions like this every once in a while. They want to know what K is, so they leave a number out. So how am I going to figure that out? Well, I know the total for that row is 62, and I know the other two numbers are 34 and 22. So I can just take those numbers away. I do the same thing with the column, and I'll get the same answer. So I'm going to take 62 and subtract 22 and 34, and it leaves me with 6. So that means K should be 6. All right, and again, there's little things that aren't worth a lot of credit, but I need to know that or I'm going to have a hard time doing some of the other stuff. So determine the number of degrees of freedom. They don't ask you this a lot. Now, you can actually get this out of the calculator, but remember, it's row minus 1 times column minus 1. There's 4 rows and 3 columns. So it's 4 minus 1 times 3 minus 1. That'd be 3 times 2, means there's 6 for the degrees of freedom. Okay, so use the graphic display calculator. So now I got to figure out what the actual chi-squared and p-values are. All right, so let me get this zoomed in here. So matrix A is 4 by 3. So these numbers have to go in there. So 28, 8, 18, 34, 6, 22, 18, 16, 24, 12, 15, 20. So there's that. I get my expected frequencies. So I'm going to edit matrix B, make it a 4 by 3. Okay, row total times column total divided by grand total. 54 times 92 divided by 221. 54 times 45 divided by 221. 54 times 84 divided by 221. 62 times 92 divided by 221. 62 times 45 divided by 221. 62 times 84 divided by 221. 58 times 92 divided by 221. 58 times 45 divided by 221. 58 times 84 divided by 221. Let's see. 47 times 92 divided by 221. 47 times 45 divided by 221. 47 times 84 divided by 221. Okay, so there's my expected frequency. We'll drag and drop that in there. Test it. So stat test, go up to letter C. Everything's in the same spot. We'll drag and drop that over there maybe. All right, so let's see. So there's my expected frequency matrix. Let's toss that guy. Keep all kinds of stuff on over there. Let's bring that guy down here. So let's see. It gives me a critical value of 12.6. So it says state the conclusion for this test. So 18.1 is greater than 12.6. So reject the null hypothesis, meaning preferred toy and age are dependent. Preferred two R's. Preferred toy and age is dependent. You can also use the p-value. So 0.005 is less than 0.05 is less than 0.05. So reject the null hypothesis, meaning preferred toy and age is dependent. You don't need to write both. You pick one of them. I would say that probably you need the p-value a little more often because they don't always give you the critical value. And if they don't give you the critical value, you'd have to look it up. And if you don't have the ability to look it up, then you can't do that way. So you need to know how to do both. P-value might happen a little more often than the critical value, but I'm not even sure that that's going to be 100% true.